Okay, now we'll talk about the derivative of a power function. So let's say you have found the derivative of x to the power of 3 and the derivative was 3 times x squared, yeah? And the derivative of x squared, we know it is 2x. And the same formula, if you apply to just to x, it will be 1. So do you see any pattern here? So do you see that the power decreases and the power becomes the coefficient, yeah? So in general form, if you can write it, will be x to the power of n. It will be like n x to the power of n minus 1. So here you have 1, yeah? Here will be like x to the power of 0, this one. So this is like the general rule, but is it always true? Let's answer to this question. Okay, to answer to this question, we need to first know the formula of difference of powers. Okay, difference of powers. So let's say you know the formula of this one, yeah? A square minus b square. It is a minus b plus a beta. Okay, you know this one, a cube minus b cube, it will be a minus b times a square plus ab plus b square. But do you know for what is the formula for, let's say, a to the power of 5 minus b to the power of 5? So you can work this out by a formula which is a to the power of n minus b to the power of n. Okay, so the first factor would be a minus b, and then comes a to the power of n minus 1. So this one, why it's so? Because the maximum power in this, if you multiply these two factors, should be a to the power of n. So it cannot be more than n plus 1. The power cannot be more than n plus 1. So the b would be here 0, yeah? So b to the power of 0, it is just 1 actually. Then plus n minus 2, and then you have n b1 here. So as you see, the power of a decreasing, the power of b is increasing, okay? So then you have n minus 3, and then b2, yeah? So it will go on. Okay, let's see the last term, yeah? Here, last term. B, how do you think what will be b? B, here, the maximum power, here is this one, n minus 1. B, a is 0. And then comes, you have b n minus 2, and then b1. Okay? So here you have minus 1. So this is your formula. Yeah, we will need this one to prove our this statement that this one is always true. Yeah, to prove this one we will need this formula. Okay. So you know that you should know this one. Sorry. Okay, let's have this one. So you have let's have some graph here. Yeah. So this, let's say this have x. This is, so if this is x, this point, yeah, this should be fx, yeah. So let's say this the range is here is h. So this one should be x plus h. This point. This one should be f of h x plus h. Okay. So the derivative of this one is you know it is so this is like f y is equal to f x. So f prime x is equal to limit as x as h approaches 0, f of x plus h minus f of x, divided by h. Yeah, this is your formula. But this one is not the only way to state the derivative. There is another way. So let's draw the same graph. Yeah. So you have this graph, and let's say that let's take this point as x, and let's take this point as c. Okay, and this point would be f of c, and this point would be f of x. Okay, and let's use this idea to make the derivative, to find the derivative of this function. The function is the same, yeah, f of y x. So the idea is this one. So f of f prime x is equal to limit. So here would be it will be remain the same, fx minus f c of c, and then here it means x minus c. Yeah? But what is the limit? How it going to approach? Yeah. So here in the first example, the idea is this one, that the distance becoming 0. Yeah. How we can get this distance as the same here? So this distance with this one. So this distance, yeah. So we should get this approaching to 0. How we can do it? We can do it by this way. So this one, this point, the distance here, it is x minus c. Yeah. So for example, you have 9 here. If it is 5 here, so the distance would be 4. 9 minus 5. Yeah. So to make this distance 0, it should be x, c should be x, yeah? So like x minus x, it would be 0. So c should approach us to x. And using this one, now we're gonna prove this statement, which is so f of, so you have this formula. So f of x, it is x to the power of n, yeah, and then you have to find the derivative of x to the power of n, which is limit as c approaches x. Using this one, fx, it will be x to the power of n. Then you plug in c, it will be c to the power of n, yeah, and then x minus c, just using this form. Okay, what will happen? Using this formula, you can say that it will be equal to limit as x approaches as c approaches x, it will be equal to x minus c, and then according to the formula it will be x minus x to the power of n minus 1, c it will be 0, and it is 1, you may not write it, plus it will be x minus 2 to n minus 2 times c, and it will go on, and the last one would be should be c n minus 1. It will be just x 1 here, because it will be 0, n minus 1 here, and then plus c n minus 2, and then you have x here, plus. So divide by x minus c. So as you can see, these two are cancelled. These two are cancelled, and you have this one, limit as c approaches x, and we have here x n minus 1 plus x n minus 2 c plus and we have all the numbers here, and we have x c n minus 2 plus c n minus 1. and our limit that c approaches to x, yeah, so c becomes x, it means, yeah, and it will be equal xn minus 1 plus xn minus 2, and this one should c becomes x, okay, do you see, plus here this one x, and this one c becomes x, xn minus 2 plus xn minus 1, okay. And now let's see what is happening here. Here you have n minus 1, and here the power is 1, yeah. If when you have the multiplication here, you should add them. So here you get xn minus 1, and this is this pattern will continue or in this area, and here you get also xn minus 1, and here xn minus 1. So they're all the same. And now let's see how many this term do you have here. How many these terms? Okay, let's remember that that our term continued from, yes, from n minus 1 to 0, yeah. So from n minus 1 to 0, how many terms you have here overall? So let's say you have, let's say 6 minus 1 to 0. It means from 5 to 0 it will be 5, 4, 3, 2, 1, 0. Overall 6. So it means n, yeah. So this overall how many? N terms. So it means that n, you just have to n multiply to x to the power of n minus 1. So you have proved this the derivative of a power function, that this is true for all power functions.